Здрасте, Бабура еще нету? Бабура какая? По-моему, он все еще на другой.
So guys, hi to everyone. I already started the recording. I want to share my screen. So can you see my screen now?
Yes.
Okay. So let's go to our folder. So examples PP1 2001. And we have here the week number 9, folder G3, and so let's prepare our frame. Okay. So before the lecture, I want to discuss about your midterm. So midterm exams already passed, and results also announced in our general channel, and in your ESP system you can also see the results. And I'm repeating again, so inside of each problem during the midterm exam, we have 100 tests. So let's see again. That's why I want to open this one. So where is the link? So inside of our midterm exam, we have the 100 tests for each problem. When we are talking about the partial solution, even if your code didn't pass any tests, which means you're sending some code and it says a partial solution, but if your code didn't pass any test, which is a 0 test, it will be also the partial solution. That's why from some students, there is a question, I have the partial solution, why I don't have the extra points for that? So for this reason, you have to go to the contest that you wrote during the midterm exam, log into that contest again and see the standings and find your name and see the solved problem past tests. And the formula, how can we get your points, will be over here. So each problem will have the 100 tests, and the problem will have the 7 problems for each contest. And as maximum, you have the 700 points as a test. And after that, it's a maximum 35 point. And from that calculation, from that proportion, you can calculate by yourself also your points. And that points will be put it in the VSP system. So after this research, if you have again the question, if you want to appeal that points that already put it in the VSP, in that case you have to go to Dean's office, or you have to contact the Dean's office and write the decree to appeal your code. And in that case, we will organize the commission for the discussing your question. And after that, we can answer and we can discuss individually with you. So I think this is clear for everyone, and you can see the results of your route. Again, if you have the partial solution, you have to see how many points, how many tests your code passed. For instance, if your code passed 50 tests, which means you have, for that problem, you earned a 2.5 point. Because the maximum score for each problem is 5. If it's half, it's 50% of that was passed. In that case, you have the 2.5 score earned for that problem. Okay, I think this is clear. And so the questions about the midterm should be, just skip it. In general channel, we have the link to the upsolving. So the upsolving of the midterm problems, we already uploaded all the problems of the all versions. We have approximately the 6 versions of the midterm exam, and it's about the 50 or 60 problems, different problems, which you have to solve to prepare yourself and to the midterm exam. So the login and password will be your ID number from the KPTU's ID will be as a login and password. And after that, you can change your password. And here we have the announcement about after today's lecture. You have also linked to the lab number 7 and the authorization to that lab number will be the same. So your ID card number will be the same as we did in our midterm absolving. So after I think the 11th week, so after the 11th lecture, we will start the end-term exam. So end-term exam will cover all the topics starting from the first week. It doesn't mean that the end-term will be only the second week, so the second attestation titles. So which means if you don't know how can you write the for loop, so it can be just skip it. The end-term exam will be always failed. That's why end-term exam will cover all the topics from the first week until the 11th or 12th week. And you can think about the end-term like a final exam, because final exam and end-term exam, they are almost the same. Both of them will cover all the topics. And so the format of the end-term will be the same as midterm. So the format will be the contest as we did in the same platform, in the same conditions. So might be the number of problems might be different. It will announce it near to the midterm, so the end-term exam. But here I have the key point. As you know, for each attestation, by the university rules, for each attestation, we have only the 30 points as a maximum. But for the first attestation, we give you got as a maximum the 35 ability to go to 35 points as a maximum. But if you earn more than 30, in that case, we can only put the 30 point. And after analyzing the results of the midterm, as you can see that most of you didn't solve any problem. So approximately 70% of the students just cannot solve any problem. It might be the cause of the online format. It might be because of the responsibility from your side. Because of the first year of student, you cannot identify and you cannot understand the environment of the university's rules. And I think they will. Yes, Ayman, you have to turn off your microphone. So it might be the different reasons might be here. So the results of the midterm. That's why in the end-term exam, you can earn 45 points as a maximum, which means you have extra 15 points as a bonus. So which means you can earn. It's not just a simple additional points. As we did in the first midterm, for instance, 7 problems, which by the 5 points as a maximum. So in the end-term exam, so I cannot say the number of problems, but approximately you can think about it, about the 10 problems. And the maximum point for the end-term will be the 45. And again, midterm points cannot be changed. Why we are adding these 15 points as extra? This extra 15 points for those students who have to take the 30 point to pass to the final exam. Because we have the rule, we already know. So the sum of the first attestation and second attestation should be and must be more than 30. So as you know, that for most of you failed the midterm exam, who got the 0 point, they have to take the 30 point in a second attestation in the end term exam to pass this course and to pass not this course, to take the final exam. If you got 29 in the end term exam, you will fail. Because some of these 2 attestation points should be more than 30. So that's why we are giving to you the 45 point as a maximum in the end term exam. So if you got the more than 30, if someone solves the problem and the results will be the more than 30, in that case, we can also just, so we can only put the 30 point as a maximum, because we cannot put the more than 30 in university's rules. So This is the rule. Any questions regarding to the interim and other organizing questions? Guys?
Teacher, I have a
Yes.
question.
So you have to raise your hand and to ask the question.
Okay. I'll raise my hand next time. Okay, teacher. But on the next station, can we use Visual Studio Code as a platform to write our codes in?
So, Batar, you have to raise your hand when you're asking the question because I cannot identify with who I am discussing the question. Okay, so thanks. So about the environment, we already discussed in the first station. So the environment will be the Visual Studio Code here, but it's up to you if you're already familiar with other editor, with other workspace. If it's comfortable for you to work in the Sublime or it's comfortable to you to other environment, it's up to you. But during the lecture time, we are showing the examples inside of the Visual Studio Code. And during the midterm or end-term exams will be only just simple codes. It might be the online scpp.h online format or devcpp. It doesn't matter. That's why it's not a problem if you are using the other editor. It's up to you. So our recommended version is Visual Studio Code, which is will not require the many space and many resources from your laptop, and it's comfortable even to solve any problem. Okay, question? Yes.
Yeah, but like on the test, like interim test, can we actually use Visual Studio Code to write our codes in on the test?
So during the interim exam, it depends on the environment that we are preparing in the KBT University's computer. So if you already passed the midterm exam, so you got the two options. First one is online platform where you can write your code. Second one is devcpp, which is in the university's, program which already installed in the university's computers. That's why don't just connect it to the one environment. You have to work in any space, and you have to you have to work in just a notepad or just a TXT files. So you have to be ready to write the code in the TXT files and compile it in the online platforms. Okay. So in the midterm and interim exam, you cannot use your laptops. You cannot use your other devices. That's why be prepared to write it in a next TXT format editors. Okay. So any other questions, guys, regarding to the extra points? Yes.
Простите, мне просто на английском не очень понял. То есть, чтобы получить пропуск, end-term и final exam, нужно получить какой-то определенный балл или как?
Так, давайте на русском тогда попробую объяснить. После midterm мы посмотрели. То есть вы должны понимать, что в университете по grading policy у нас есть правила. Есть две аттестации. Первая и вторая аттестация. Максимум за каждую аттестацию вы можете набрать по 30 баллов. Это в сумме 60 баллов, правильно? И у нас есть финальный экзамен, который весит 40 баллов. В сумме у нас 100 баллов. Это максимум, это A+. Теперь, после midterm у нас максимум за первую аттестацию мы можем поставить там 30 баллов. Но мы давали там 5 баллов бонуса, чтобы вы могли там набрать больше. 35 баллов было на midterm. Но если у кого-то будет реально больше 30, если кто-то набрал 35, тогда ему по-любому мы поставим 30, потому что мы больше 30 не можем ставить. И эти баллы не переносятся на следующую аттестацию. Теперь, после первой аттестации, то есть после midterm, после анализа, мы понимаем, что очень много студентов ничего не решил. То есть очень много студентов, кто получил 0 за первую аттестацию. Теперь у нас есть правило. Первая аттестация плюс вторая аттестация должна быть больше или равно 30. Эта операция, надеюсь, всем понятна. Это правило. Если у кого-то будет первая аттестация плюс вторая аттестация меньше 30, например, 25, сумма этих двух аттестаций баллов, тогда у него сразу будет фейл. То есть он финальный экзамен не пишет. Это понятно, да? Теперь те студенты, которые набрали 0 за первую аттестацию, то есть за midterm, у них есть шанс, чтобы набрать 30 баллов на вторую аттестацию. Если они набирают меньше 30, например, 29, они сразу же получают фейл. Потому что вот условие, которое мы ранее говорили, оно не выполняется. За первую аттестацию у них уже 0, за вторую аттестацию у них 29. В сумме 29, которым меньше 30. Что означает фейл. Это до экзамена. Поэтому те студенты, которые набрали 0, у них стоит задача за вторую аттестацию получить 30 баллов. Меньше 30 уже не пойдет. Поэтому во время эндтерма у вас есть возможность набрать максимум 45 баллов. Это означает, что 15 баллов сверху. Это значит, может, задача будет больше, может, задача будет весить больше, не 5, а побольше. Или количество задач будет увеличиваться. Это вот чуть позже, когда уже ближе к эндтерму скажем. Но суть в том, что вы можете набрать 45 баллов. Мы даем это для того, чтобы те студенты, которые набрали 0 за первую аттестацию, имели какие-либо шансы набрать 30 баллов, чтобы пройти на финальный экзамен. Надеюсь, понятно объяснил. Это значит, если вы набираете больше 30 за вторую аттестацию, мы поставим по-любому 30, и эти баллы никуда не переносятся. То есть баллы, которые вы набрали сверху, не переносятся на финальный экзамен. Финальный экзамен – это отдельный экзамен, который весит 40 баллов. Вопросы по баллам еще есть? Иркижан? Иркижан? Микрофон нужно включить.
Ага. Так что часа будет на все или еще добавят время?
Еще раз. По времени? Это зависит от задач. Вот как мы уже определимся по количеству задач во время midterm, это уже от этого зависит. Возможно, будет чуть больше, возможно, будет такое же условие. Посмотрим. Это еще неизвестно. Но количество задач по времени, это будет уже ближе к midterm известно. Главное, что вы должны сейчас понимать, это максимум вы можете набрать 45 баллов. Так. Еще вопросы? Okay, если вопросов нет, we have to go back to today's lecture. So by our syllabus, so if you open our syllabus, we have, after the midterm, we have the big title, which is a complex title for some students and for most students, which is the recursion. Recursion, it's just the extended title of the function. So about the functions you already know. So we have to start from the examples. So we know that we have the two types of the functions. First one is void function. Second one is data type function. Okay. I want to show that the simple code of the programs. So about the function and function call you already know. So about the main, I'm calling this show function. And in the 13th line, compiler will go back to the function and it will implement the lines inside it. So, okay, I think that's clear. So see out line 2. Let's imagine like this, line 2, and we have the several lines, line 3, 4, 5. Okay, if you run the code, you will get this like a result, and this is abuse. And we know that void functions cannot return any values. So we have the data type value, data type functions, which can return the data like this, returning some number, which is an integer. But void functions cannot return anything, but they can be manually stopped. For instance, for stopping the for loop, you have to write a break to stop the manually or for loop. But to stopping the execution of the void functions, you can also return, but without any data. As you can see, you can return it, but without any data. If you run the code, in that case, you will have only the line 3 as the last output. These 2 lines will be skipped. Why? Because we are stopping the function manually in the 9th line. I think this is clear. So let's move on and extend these examples. Okay, so the returning function, which can be like this. So let's create another function, show2. Cout hello kbtu. Okay, hello kbtu 1 and copy it to 3. Let's imagine like this. And I want to call the show2 here inside of the main. And it's our second example. If you run it, you will have obviously this output because I'm calling the show2. If I am concurrently calling the show here, let's rename it like a show1. If I'm calling the show1 here, in that case, it will implement the show1 at first here until the return, because I'm stopping the code here. But pay attention, you cannot return the some number here, or some other data type, or some true, false, and so on, because it's a void function. Void function cannot return anything. That's why it can be returned, it can be finished, but it cannot return some value. Pay attention. So I'm calling the 2 functions step by step. What will be if I'm calling the second function, and inside of the second function I'm calling the show1? Can I do that? I can do that because both of the functions correctly implemented, so they correctly defined. So I'm calling only show2 inside of the main. Show2 will be executed one by one. Compiler will execute each instruction, and in 19th line, show2, compiler sees that I'm calling another function, and it will loop through the show1 function inside it. Show1 function will be executed and finished. As you can see, hello kbtu1, it's function 2, and after that we are calling the function 1. I think this is clear. If I'm putting here for instance, let it be the kbtu4, and let it be the 5. In that case, as you can see, after the showing the content of the show1, compiler will continue working after implementing this one. Compiler will continue working inside of the show2. As you can see, the hello4 and hello5 will printed out here, because after finishing the execution of the show1, compiler will continue executing the rest of the previous code, previous function. This is the key point that you have to understand. So let's move on. So what we want to do, so let's remove the show1. So we know that inside of the one function, we can call another function. Okay, it can be clear. But what will be if we are calling inside of the show2 again? Can I call it? So I'm calling inside of the main function show2. Show2 will be executed and printed out something. And inside it, I'm calling again the function itself. So if you compile it, you will have such like a result. So it will just infinitely continue calling the function to itself. And in some case, after the some iteration, It says segmentation fault. In other words, it's an error called Stack Overflow. About this platform, you already know. So all of your questions regarding to the programming can be found in that platform. So in that platform, which is a very useful for solving any problems, and community, which is which can be very easy and comes from here. So what does it mean? It means for each function, there will be the stack. What is the stack? We will discuss a little bit later. So when I'm calling the function, and the function calls itself, oh, sorry. So just a second. So what is the recursion? Recursion is when function calls itself inside it. So our function calls itself inside of this function. And this one is called the recursion. This process and this logic called recursion. But we have the list of rules which have to be implemented inside of the recursion functions. So as in this example, if you are running the code, you will have such error depending on the operating system. If you have the, for instance, of Windows, in that case, this code can continue working infinitely, and you have to stop it using the Control plus C button to stop them manually. So the recursion is such like an operation. So the function calls itself. But if you are not running and not calling the so-called base case, in case you will get the Stack Overflow error. It's an error which says infinity calling function itself. So the Stack Overflow, it's just an error which says your function calling itself, but function cannot identify when it should stop the working. And in that case, you will have such like a result. Because stack, which will store the list of the instructions, will be overflowed. It cannot store any more data because your function works very infinitely more times. In that case, you will get such like a result. For escaping and solving that problem, you have to be careful to write the base case. Base case, what is the base case? It's the finishing point of recursion function. So what does it mean? You have to write some condition inside of the recursion function, recursion process, to say this in some cases, finish your program. So in our case, it cannot be finished because we don't have any condition. It will just call and again, see how this output and call it again. So let's copy this one and put in the next example. and try to write a base case. So in our case, in our example, we don't have any rules. That's why I'm just creating the variable, so the global variable a, and let's a will be incremented every time, and I want to print out a here, and condition if a equals to the 1000. In that case, I want to return. So why I'm showing in the previous examples return, because which means void functions can be also finished using the return keyword. So I'm saying if a equals to the 1000, in that case, I have to finish it. So if you run the code for CVP, in that case, you will have the output. And as you can see, each time it will call itself again and again. And when a equals to the 1000, as you did here, it will just finish the working and without any errors. It's just an example. So it's just an example. It's a base case. Function calls itself. So this function calls itself again and again, but in the base case condition, it should stop. So that's why it's just a key point. So when you have the task for the recursion, first task for you is to just identify when you have to stop the working of the process. Okay, let's continue. So the fifth example. Okay. I want to remove everything here and see our plan. Where is the plan? Plan is over here. What is the recursion? We already discussed the base case. Okay, the Stack Overflow. Okay, and here we come from the examples. Example says, so the task is show the numbers from 1 until the n. It's the first part of our program. You have the number n. So let's get this number from the terminal. Let's imagine that n is equals to 4 or 5. In that case, the result should be 5, 4, 3, 2, 1 as a first solution in a decreasing order. So let's define here the function called void and f1. F1 is a solution which is a traditional using the traditional methods that we already know. So let's take this n, and I want to call here the f1 and pass the number n. So that this number n, which is a 5, will be passed here, and your task is print out these numbers. Any ideas how can we solve this problem using the traditional methods that you already know? Forgot about the recursion. You have to solve it using the traditional method. Output should be like this. Any ideas? Guys, are you with me? Oscar? Oscar, any questions?
No,
So any ideas to solve this problem?
no, that's my idea. We need to shout n and decrease n.
Okay, shouting the n and decreasing n, but if you are writing it like 1 times, so printing it like 1 times, it will just print out also the 1 time element, but you have to show all the elements until the 1. This one will print out only 1 times.
This we need to do f1 inside f void f1.
So we are just solving it using the traditional method, not using the recursion. Forget about the recursion and solve this problem. How you will solve?
We can just call f of n minus 1 side of f1.
So I'm passing here the number n, and again, forget about the recursion and solve it using all the knowledge that you already know.
Like with loop again?
Yes,
we can just create for loop and run from the last number until the zero. So
No, it can be the zero, okay. Might be the minus minus, and do it like this, isn't it?
yep.
I'm just asking about it because F1 functions for all examples that we will discuss now. F1 will be the traditional and already known method to solve the problem. So it says starting from the 5 until the 1, we want to print out the results, which means, oops, what? No, here we have the I. Here I have the I. Let's do it again. It's a 5, and here we have the result, which is this one. Okay, I think this solution is clear to everyone. And we want to create the F2, which is the second function. And F2 should be implemented for the same problem, should be implemented using the recursion. So you're given one number, you have to implement this one. But F2 should be implemented using the recursion. Any ideas? What do we have to do when we are talking about the recursion? What we discussed in the previous examples. Recursion is this one, base case is this one, and the second overflow is this one. What is the steps which we have to do to solve the recursion problem? First of all, what we have to do? Guys, are you with me? Askar, again, you're raising your hand.
Okay.
So when I'm asking about the solutions, you can, without waiting, without raising your hand, you can answer the questions.
Okay. First of all, we need to shout n and decrease n by 1. Then call F2 inside void F2.
I want to see out n first of all, and you are saying about decreasing the n, and after that,
Yeah.
what I have to do?
Calling F2 inside void.
So F2 calling and passing the what?
Int n. Yes.
Int n, it's another passing the value. It's just declaring the function. This is syntaxically incorrect. So that's why to solve the recursion problem, first task for you is to identify the base case. So your task is, you are given one number, you have to, starting from that number until the 1, list all the integer numbers. Base case is when you have to stop your recursion. How do you think when we have to stop the recursion?
When it's equal to 0.
When n equals to the 0, in that case, so let's write like this. When n equals to the 0, then stop recursion. Okay? So let's write immediately. When I'm writing the recursion function, you have to be careful about the base case and immediately write your base case. If or n equals to the 0, in that case, I want to return it. Okay? Please, when you are writing the recursion, you have to start from the base case. Identify the base case and start from there. Okay, sorry. So we identified that n equals to the 0, it's the current element. If it's equals to the 0, in that case, we want to stop it. Otherwise, if n not equals to the 0, what I have to do then? I have to, discuss it as we discuss it with your group mates. We want to print out n and we want to decrease the value of the n. And after that, to convert this f2 to the recursion function, you have to call it. You have to call it and pass there the next element. So let's see. So 0, it's identifying the base case. The first one, f2, and number is, let that be the 4. So what will be when we are calling the f2 and passing the 4? The 4 is not equal to the 0, which means this one is skipped. Print out 4, which means cout 4 will be executed. Cout 4 will be executed. And after that, n decreased by 1, which is n becomes as a 3. And f2 called with the number 3, isn't it? And this one calls f3 over here. It will print out 3, and it will call f2. And in third iteration, f2 will be executed, and 2 will be printed out, and it will call f1. And in fourth iteration, f1 print out 1, and it will call f0. And in fifth iteration, f0 will be executed. And how do you think? If is f0, f2 0, if n equals to the 0, we say that it should finish. So after that, it will just return, which means it will just stop execution, which means just a stopping point and base point will be reached, and these numbers will be printed out. So let's try. So for trying, I have to change this to f2, which is a recursion function. So the fifth example, and run it, and number 4, 5, and 10. As you can see, we implemented the same thing as we did here using the recursion function. First of all, we have to identify the base case. So we already identified that n equals to the 0. In that case, we have to stop it. So we write this code. Otherwise, if n not equals to the 0, in that case, I want to print out the n and decrease the n. Why? Because I just want to print out the decreasing order values. So you can also remove this line and put it like this. So when I'm calling the function itself, I'm calling with the n-1 value. If it's a 5, I'm calling it with the 4. If it's a 4, I'm calling it with the 3. And if it's a 3, I'm calling it to 1. And the last time, when n equals to the 0, it will reach this condition, n equals to the 0, and it will stop it. So if you just remove this code and you forgot about the base case, and if you will run such like this code, if you compile it and if you run it, you will got the, as we can guess, you will got the segmentation fault error, because n never will be reached, and it should not finishing everything. So it will just see out n and again, and every time it will just decrease if it's a 5. So if it's a 5, it will just print out, and after some time you will go the segmentation fault, because it goes to this number, and after that stack will be overflowed, and it will just stop the execution, because you are not writing your base case, stopping case for this function. So which means function called infinity times. That's why you have to start from the base case. Okay, let's move on. If you have questions, please take a note. I will give the time a little bit later. We want to extend this example. So now the task is, you are given a number, but you have to write in an increasing order. So the task is increasing order solution. Let's implement it using the traditional format, as we already know, F1. For that, I have to start from the 1, and it should be changed to this one until the n. And here I have the I++, and we'll just see out it. Oh, sorry. We want to execute the number 6 and 5, which means from 1 to 5. And this is our simple solution that you already know, and you have to understand it. And you have to immediately solve this problem using the traditional for loop. Okay, the same task we want to implement using the recursion. So let's remove everything here. Oh, sorry. So let's remove this one. So let's try to understand about the recursion function and to implement this operation. So the increasing order numbers. So how can we solve? First of all, we have to think about the base case. Base case will be the same. So the n equals to the 0. In that case, we have to stop. If n equals to the 0, we have to stop it. Otherwise, you have to separate the current problem to the sub-problems, which means n minus 1, it's just a sub-problem. If f is a 5, f5 we are calling. We are creating a sub-problem like f4. And after that, we're creating like a sub-problem like a f3 and so on. So that's why we are not printing out before the calling the function. We are just removing it, putting it after the calling the function. What will be in that case? So let's discuss. So I'm calling the f2, this function. I'm passing the number. Let it be the number 4. 4 number will be called here. 4 is not equals to the 0, which is goes here. And as you can see, after the if condition, we are calling immediately the function itself without any shouting and without anything else. But we have the rest of the function for each iteration. So function starts from the opening curly brackets and finishes within the closing curly brackets. When I'm calling the function, it should execute everything inside it. But we know that inside the function, we are calling again our function. But we have the rest of the code which was just skipped and not executed. For this situation, we'll be using the stack as we discussed before. So base case is the same as we discussed here. So for the F2, we'll be use the stack. What is a stack? Stack is just a vertical. You can think about it like a baggage, vertical box or vertical some space where can be stored the instructions. Stack is a box. For instance, you can think it like this. Let's imagine like this. So this is our empty stack. Let's imagine that this one is vertical box. And when I'm adding to the stack some element, for instance, I am adding to some number, let it be the 3. It will be added from the top and put it to the box. For instance, we have the empty stack, that's why the number will be the inside of this stack like this. After that, I want to add to that stack another number, for instance, number 5. 5 also will be put it from the top, and 5 will be stored over here. And after that, I'm adding another number, for instance, -1. -1 will be added from the top, and it will be stored over here. Again, I'm adding the new number like 10. 10 will be also added from the top. And for adding the new element to the stack will be from the top, and extracting the data from the stack also will be from the top, which means after adding the 3, so the add 3, add 5, add -1, add 10. After that, when I'm getting the data, it will start from 10. It cannot get the 3 as the first element. When we have some stack, and if I am telling to the stack, give me some data, it will start from the top of the stack. It will get the 10 and it will remove it. And after that, if I'm sending it a request to get the new data, it will return the -1. And it will return the -1. And so on until the empty stack. So this one called first in, last out, or last in, first out. Last in, first out. So data which was added lastly will be getted first. So the last in, first out. Last element which was added 10. That's why when I'm getting the data from the stack, it will be getted as a first element. This is the rule, and this is the logic of the stack collection. So I think this is clear to everyone. So let's put this explanation a little bit here to understand, to put here. So stack logic of the stack will be like this. So the last added element will be extracted firstly. But when I'm adding the new elements will be added from the top. For instance, after the 5, if I'm adding the 6, 6 will be appeared not in the after the, for instance, here. It will be appeared over here. From the top, I'm adding the new data. Okay, I think the stack is clear to everyone. So inside of the functions, when I'm executing the something, we know that inside of the function, we are just calling the number, so the number 4 here. So the first iteration, F2 called with the number 4. So we are executing it manually. And F2 function called with the number 4. 4 is not equal to the 0, which means this condition will be skipped. And we are immediately calling the function with the number -1, which is we are calling the function 2 with the number -1, which is a 3. Isn't it? We are calling it inside it. But for the current iteration, when n equals to the 4, for the current iteration, we have the rest of the code, which is cout n. N in our case, number 4. But this cannot be executed because we are calling the function again. After the 14th line, or the 14th line, compiler should start the function again. But this one cannot be just just forget it about it. So it should be executed after the sometime after finishing this function. If you go back to the second example, when I'm calling to this function 2, it will implement these 3 lines and it will go to the show 1. After the finishing this show 1, it will continue working here. The same thing over here. When I'm calling the function, I will execute everything here, and in 14th line, I am calling not another function, but function itself. That's why I have to remember this one, so that this line for the current iteration. So that for the current iteration, n equals to the 4. That's why this instruction will be stored inside of the stack. So the rest of the function will be stored in stack. Let's imagine that we stack L, which is over here, like an empty stack. When we are running our code, the empty stack was created. So we know that in 14th line, we are calling the F2 with the number 3, but this code will be executed inside of the stack. Stack L equals to this instruction will be stored inside of the stack, but instead of the n will be the number 4. Why? Because we are running the function with the number 4. So this data stored in our stack. Why? Because we are going back after the 14th line, going back to the 10th line to run our code. Okay, so in the next iteration, I am calling the number, so that this function will be executed, which means this function executed, 3 is not equals to the 0, and again it will call the function 2 with the number 2. Number 2, but for the current iteration, the rest of the code will be also, so the rest of the code, this one, should be stored in our stack. Again, think about the stack. If we have some data inside of the stack, when I am adding the new data, it will be added from the top. But in our case, our stack located horizontally, that's why we have to understand that our adding data will be like this. So in our stack, there was one instruction from the previous iteration. But for the current iteration, I have another instruction. For the number 3, I have cout 3. And as you can see, I'm adding before the for this instruction. Again, the same thing. So which means this function will be executed. This function will be executed. And 2 is not equals to the 0. And again, it will start from the 1. Which means for the number 2, I have to add one more instruction because we have here this instruction. Here we have the number 2. Again, so it's a 3, it's a 4. So we'll be executed this function, f2 with the number 1. 1 is not equals to the 0, but we are calling here this f2 0, which means I have to add here the instruction for 1. Cout 1, it's the current instruction which is not executed yet. So the last operation, which is f2 with the number 0. So f2 called from the 0, which means if n equals to the 0, we have to finish, which means return, stop execution. Base case. Okay, when f2 called with the number 0, as we put it here as a base case, we are saying that we have to stop execution and everything. But after this time, compiler will check for empty stack. Empty stack. If stack is not empty, as in our case, stack is not empty because we have instructions there. In that case, if it's not empty, in that case, it will start execution one by one. One by one, extracting data from the stack. So here we have our stack. We have added one by one our instructions that we have to implement after finishing this 14th line. 14th line, finish it here. And after that, it will just one by one implement the instructions inside of the stack. So when I'm telling to the stack, give me one element, as we discussed here, if I'm telling here to give me one element, it will give the 5, which is the last added element. As you can see here, I have the last added element is this one, cout 1. And after that, it will print out 1, it will remove this one, and again, it will get the second element, second instruction, and it will print out 2, 3, 4, and after the stack becomes as empty, after that it will just finish the program and finish everything. So in a second example, there was the same thing. So even we don't have here the recursion, how it will work. So I'm calling only the show2. It will implement these 3 lines, and after that it will go to the show1, and it have to somehow identify that after finishing show1, it will continue working here. So that's why these 2 lines and 2 instructions will be stored inside of this stack. So why we have the stack overflow? Because this stack becomes very big data. After some time, stack will be overfitted and overflowed, and it cannot store any other instructions. In that time, you will have the stack overflow error when stack is already filled and it cannot add new data to the stack. And this is our key point, that you have to be careful and write the correct base cases. Okay, it's time to your questions. Please raise your hand and ask your questions. Guys, if you are with me, please raise your hand and ask your questions. So there might be the only two cases. If there are no any questions, from your side, there might be only two cases. First one is everything is clear and you don't have any questions. Second one is you cannot understand anything and you cannot ask some question. So I guess, and I think, and I hope we have the first case, because this is just a complex title which you have to understand and which will be covered in an end-term exam. So, Oscar? Yes, Oscar?
I did understand the stack. So how it works?
So say it again, I cannot hear you.
I mean, I didn't understand stack. So it adds first element in bottom.
Yes, think about the stack like a vertical box. Can you understand? Like a vertical box or vertical some baggage. And when you are adding the new data, you will put from the top. If it's an empty stack, so empty box, so the vertical empty box, if you are adding the new data, you will put from the top. From the top, but it will be stored in the bottom of the box, isn't it? If you are just throwing some data to the box, throwing some paper to the box, it will be stored in the bottom, like a free like this. And you are throwing another box, another, for instance, ball to the box. It will be stored after the first one. Next element will be stored after the first one. And when you are taking the one by one element from the stack, you will also, because bottom side is already closed, you can also only take from the top side, from the top of the box, opening the box. So you will get one by one from the top these elements. And this is called the last in, first out. So last added box, last added ball will be extracted firstly. And again, you will get, so very first added ball will be getted only as the last element. This is a rule of the stack. And what we did here is the same thing. So we are adding here so these operations will be done by the compiler automatically. We are not creating, as you can see, we are not creating here manually the stack. We are not adding the data and we are not executing the data. So we are just explaining how it will work inside it. When I'm putting this out after the calling the function, it will be executed like this. When I'm putting it before the calling the function, it will be just simple one. It will just print the data and call the next element. Print the data, call the next element. When it reaches to the 0, it will just finish. But in an increasing order, when I'm counting after the calling the function, this rest of the code, so the rest of the function, should be executed for each iteration. When n equals to the 4, this one should be executed. When n equals to the 3, so that this one will be executed, and so on until the 1. When f equals to n becomes as a 0, f2 calls with the number 0. In that case, we finish the code. And after that, after finishing the code, compiler automatically will check the stack of the function. So stacks will be created for each function, even if it's not a recursion. For instance, for F1 also we have the stack, but inside of the stack we don't have any instruction. So after finishing the function, compiler will check the stack for the empty. If it's empty, it will just finish. So they completely finish the function. If it's not empty, as in our case, if it's not empty, it will just one by one extract the added data, so the added instructions, one by one, and extract them and implement. Why here we are using the stack? Because, for instance, what is the second example? Why we are using the stack? Because after finishing the show one here, I have to somehow continue executing as before. So I have to implement the line 20, I have to implement the line 21, and so on. If you are using the other collection like arrays or like other collections, you cannot implement it like correctly. So after finishing the show one inside it, so that theoretically the compiler should continue working here, as we know from here. So if I am calling the show two, we know that compiler will compile 15th line, 16th line, 17th line, and when it goes to the 19th line, it will go to the function. After finishing the function, it will continue the 20th line, 21st line. But when it goes to the function one, it somehow have to remember that it should be continued, isn't it? So for knowing that it should continue after the show one, because inside of the show one we are saying return 0. If we don't have any stack and if we don't store the other instructions, after the show one it will finish the program. Even we have here our other instructions. That's why this rest of the code, rest of the functions code will be stored in the stack, and they will be executed one by one, as we discuss here. So Ramses, please.
How understand how many places in the stack?
How many? So if I'm understanding the correctly, you are asking about the size of the stack, isn't it?
Yes.
So the size of the stack, it depends from your laptop's memory. Inside of the laptop, you have the read access memory. For some students, it might be the 2 gigabytes. For some students, it might be the 28 gigabytes. It depends on that, and it depends on the configuration of the C++ installation. So obviously, if you have the 2 gigabytes of the RAM, you can implement the not big, deeply. So if you are running the F2 and passing there, for instance, 4, I think that any of the RAMs will be executed. So if you are passing here this number, for instance, to the F2, which means your stack have to store how many elements we have here. Those instructions will be stored inside of the stack. So that's why if you have the less RAM program, so the RAM memory in your laptop, it depends on your task. So for some laptops, this number also can be implemented. For some laptops, this number is a maximum. It depends on your RAM. But for our programs, for our lab works, and for the end-term exams, so it's enough for even if you have the 2 gigabytes of the RAM, because we are not giving to you the number n, which should be the 1 billion or 10 billions or 100 billions. There might be the much more less numbers to execute. So we have to just understand that you can write some recursion and solve the problems. So I think there didn't be the problems with the memory of the stack. So theoretically, the stack size will depend from the RAM's memory. Okay. And it will automatically identify it when you are calling the function. So you cannot set. So you can also again set when you are installing the C++, you can set the stack size. So when you are calling the function, you can also the stack size, but it doesn't necessary for our problems. So guys, any other questions? So yes, Ali.
Извините, у меня вопрос не по этой теме, а по интерму.
Просто сегодня урок был у Бахшабаева, и он там на уроке сказал, что у них интерн будет на 45 баллов. У нас тоже так будет?
Вам нужно подключиться к уроку чуть пораньше, мы как раз таки вначале об этом обсуждали. Али, если вы опоздали, тогда нужно будет уточнить у других. Если после вашего подключения, если мы не обсудили, тогда уточните у других. Если будет потом еще вопрос, тогда можете в директ месседж написать.
Все, спасибо.
Any other questions, guys, regarding to the recursion? So any other questions? Ali, you have questions? Ali, you're raising your hand. Any questions, guys? Okay. So again, I'm repeating that this title, this topic is a little bit confusing and complex task for one lecture. So that's why there might be many questions, because I think that everything is clear, but so I will give the 5-10 minutes break time to think about your questions. After the break, and we'll start from your questions, and we'll continue learning the examples. Okay, I have the break for 5-10 minutes. So guys, let's continue. I want to put here the example. Okay, let's remove this one. So the next example should be, so the reversing the function. So the next one is a factorial. So the task is we have to implement the factorial function. So as always, if it's a 4, it should be the multiplication between them. Multiplication, and the result is 24. Let's implement it traditional format at first, and after that we'll try to create a recursion function. So the F1 is the traditional format for the factorial. So any ideas? You already solved this problem many times. How can we solve if we have the number n and we have to find the factorial of that number? So any
We
ideas?
can solve it.
So say it again.
We can solve it through 4.
Yes, using 4. What I have to do?
Here r equal to 0, integer will be plus until n. Then we will put another symbol, for example, sum. So
So yes, let it be the key.
on every we'll multiply sum to I.
So so let's do it like a k. K should be equal to the which number?
1.
1. Why 1?
If you multiply with 0, so our answer will be 0. So we should put
Yes.
1.
Perfect. So because of the multiplication, we have to create the variable with the 1 value. After that, as suggested your group mates, we will start from the 1 and work until the n. And we'll take the each value, and k will be multiplied by I. And after the for loop, we want to return the value result like k. It's a 7th example. It's a void. It should be the integer, isn't it? It should be the integer because we are returning the value. So as we can see, recursion function can be not only inside of the void functions implemented, but also inside of the data type functions. So we didn't implement yet, but we'll continue. So the integer and integer. So cvp, if you run it, and if it's a 4, oh, the As our f1 function will return some value, we have to see out the returned value. So let's compile it again. Number 4, and the result is 24. And this one is clear to everyone. So, and the same thing, but you have to implement it using the recursion. Let's clear everything here. And we know that the returning value should be the integer. And let's put here the space and call the f2 and pass there the n. So the f1 and f2, they should return the same value, like in 24. But f2 will be implemented using the recursion. So again, what do we have to do when we are writing the recursion? Yes, perfect. You have to find the base case. So the task is to find the factorial of some number n. How do you think the base case is? Which case will be the base case? So, any ideas? Any ideas which case will be the base one?
Вас не очень слышно, там какой-то шум.
So, can you hear me now?
Yeah.
Okay, so I'm asking about the base case. Which case? Yes, say it.
F1, F2 of 1 is equal to 1.
So you can say it very simple. So when our n equals to the 1, for instance, if our given number to find the factorial, if n equals to the 1, factorial of the 1, which number will be? 1. This one is very simple, isn't it? If I'm asking to you, find the factorial, immediately find the factorial of the 125, you cannot do it, isn't it? But if I'm asking to you, find the factorial of the 1, you can immediately say that this is the 1, isn't it? So this case, this question and this answer will be the base case. To find the base case, you have to find the function result when you can immediately answer to the question. Are you with me? So this case will be the base case. So if our given number n equals to the 1, which means if someone says to you, find the factorial of the 1, you can immediately say the 1. So if someone says, find the factorial of the 43, in that case you have to calculate it. So that's why, so base case means to find the minimum simple task for this problem. So for factorial problem, very simple task is when n equals to the 1. The result is 1. So immediately write this condition. If our given number n equals to the 1, in that case, result will be the 1. Return 1. Why? Because return 1 because it's an integer. So if it's not equals to the 1, in that case you have to try to find the calculation from using the using the recursion. So n equals to the 4. For instance, f2 we are passing number 4 as in our example. So 4 entered here, so f2 called here the 4. f2 4, what does it mean? If f2 4, if someone says to find the factorial of the 4, but you cannot understand, let's imagine that you cannot understand f2 number, so the factorial of the 4, you cannot calculate, but you know that to find the factorial of the 4, you have to calculate 4 multiplied of factorial of the 3, isn't it? Do you agree with me? You cannot do the calculation of the factorial of the 4, but you know that the factorial of the 4 is a 4 multiplied of factorial of the 3, isn't it? Do you agree with me?
Yeah.
This one is just separating it to the subtask, just a simple task. And again, if someone asks to find the factor of the 3, again, you cannot understand it and you cannot do it, but you know that to find the factor of the 3, you have to multiply 3 multiplied by factor of the 2. And the same thing for the factor of the 2, you have to implement the 2 multiplied by the factor of the 1. And for the next iteration, for factor of the 1, we have already base case. Here we have the base case when n, this passing data, equals to the 1, result is 1. In that case, result is 1. If factor of the 1 is the result is 1, this result will be passed to the previous step, so that it will go back and to go up to the root problem, which is a complex problem. As you can see, we solved a very simple problem here. We know that the factor of the 1 is 1. And we have here the calculation. So this one will be passed to the previous step, and it will become like a 2 multiplied by 1, which is equals to the 2. And this solution already finished, and this solution will be passed to the previous one. And here we have the 3 multiplied by 2, which is equals to 6. And as you can see, factor of the 3 also calculated, and this value will be passed up for 4 multiplied by 6, which is 24. Okay, I think this is clear to everyone, and this is just a simple mathematical, isn't it? So this one, this separation, and this one is logically understandable. So to find a complex task, we are just rearranging and rewriting the same. So this one is just an equal sign. So this part and this part, they are the equal. So you can think about it like this. So this part just rewritten like this, because both of them is factorial of the 4. By the definition of the factorial, we know that it should be implemented to find the factorial of the 4. The number 4 should be multiplied to the factorial of the 3, and what we did here. And as you can see, we have the solution here. And this one is just a simple iterations what we have to do. So we already passed the base case here. And if it's not equal to the 1, so that if n is not equal to the 1, in that case, we have to write this one. In our case, 4 multiplied by f2 3, which means n multiplied by f2 n minus 1. And that's it. Think about it. So that if I'm calling the function with the number 4, number 4 comes here, 4 is not equal to the 1, and it goes to this part. And this execution will be executed. And 4 multiplied by, again, we are calling this function, which means this part separates the function, call this here, and it will be separated again until our base case. When it reaches to our base case, when n equals to the 1, it returns the 1, this part. And all previous steps, as we discussed before, will be stored in our stack. These executions will be stored in our stack. When the last step will return some value, it will go back and put the returned value to the previous expression, because this one is this one, same thing. And from this one, the result will be passed to the previous one. Factorial of the 3 will be passed to the previous one, and so on. So let's try it. Number 4 and number 5. Okay, if you have questions, please take a note. So we will continue. And the next example is sum of the digits until the n. So this is almost the same task. So if I'm entering the 4, you have to find the calculation of this sequence. So like this, here I have the 10. So the given number, you have to find the sum of the all numbers until you're given a positive integer number. You have to find the sum of the all digits until this number, which is number 10. Again, let's start from the traditional one, as we know from the previous lectures, f1. F1 is just the same thing as before, but instead of this 1 will be the 0, and instead of this multiplication will be to just sum. And that's it. If you try it, for instance, if it's the 8th one, if it's a 4, the first value it's a 10, which is a correct solution, which is the sum of the all numbers over here. And for now, it's time to write to the factorial. The factorial is almost the same as before, as a factorial, but instead of this multiplication will be just a sum. And that's it. Everything, everything here will be the everything here will be the just finding the sum of the values. So this one is 2. Here we have the 3. Here we have the 5. Oh, sorry. So I have the 1, 2, 3. So 3 here. 2, 1, 3. Here we have the 3, and here we have the 6. 3 plus 3 here, the 6, and here we have the 6 and 20. Oh, sorry, 10. So the result is 10. So the process is the same, but instead of the multiplication, we are putting here the sum of the values. And as you can see, they are the same thing. So currently we are solving this problem using the 2 traditional and using the recursion function. Again, recursion is when we are calling the function itself inside of this function. So I will move on. So the next example is power. About the power we already know. So the power means 2 to the power of 3 is 8. So which means you have to here get the 2 values. Sorry, A and N. A and N. So let's implement it firstly using our traditional method. We are pressing here the A and N. So F1 will take the 2 arguments. So integer A and let's remove the content. And this one will do. Okay, so any ideas how can we solve the problem when we are getting the base 1 and exponential 1, 2 numbers, and you have to find the power of that number? Any ideas? Guys? So any ideas, guys? So this problem we already solved during the lecture time. So if you don't have any ideas, which means you are not analyzing our lecture examples at your home, and this problem will be just a simple problem during the end-term exam. This problem will be assumed like a simple problem, and there will be the more complex problems than this one. So that's why I want to show the explanation. So 2 to the power of 3, which means 2 will be multiplied by itself 3 times. So that's why we have to write a for loop, which will work n times. It doesn't matter, you can start from the 0 or you can start from the 1, but it should be the n times. If you are starting from 0, you have to remove the equal sign. If you are starting from the 1, you have to put here the equal sign, which means 4 works n times. And here we are creating the k again. But we have to implement this expression, but instead of this one, we are implementing this one, which is also the same thing as before. Inside it, we are just k multiply a n times. So 4 works n times, and k will store the k initially equals to the 1, multiplied by 2, this one, and the result will multiplied by 2, this one, result will multiplied by this one, which is the 3 times will be executed. And after that, we will return the key. Okay, it's a nice example. If you run it and 2 and 3, the result is 8. I think this one is clear. So the task is you have to implement the same thing. So you have to get here the A and N. So F2 and A and N here. So the F2 it's our recursion value. So any ideas what we have to do when we are writing a recursion function? So again, let's think about the given task as a complex one, and you have to find a very basic solution of the given task. And this one will be the base case. So any ideas? Yes, say it again.
Where if n equal to 0, a will be 1.
Yes, perfect. This one is just a perfect. So if I'm asking to you to find, for instance, 20 power of the 31, you cannot say the answer immediately, isn't it? But if I'm telling that 201 and power of 0, you can immediately say that this is 1. And your task is, when you are solving the recursion function, your task is to find such like a case, and this one will be the base case for your problem. So it says if n, when n equals to the 0, so the result will be equal to the 1. Say it again. If n equals to the 0, so the result will be the 1 immediately. Because it doesn't matter which number a. If n equals to the 0, the result will be the 1. So, okay. It's 8. 2001, here we have the 0 and here we have the 1. Okay, if it's not equals to the 0, this one is, so let's write here the solution. So the first iteration, or F2, and I'm passing here the 2 and 3. 2 and 3, which is the base one and it's power 1. Okay, I can write this expression. So the task for the recursion functions, you have to always divide your complex problem to the simple ones. Again and again until you will reach the base case. So base case says n equals to the 0. That's why second one is n, and you have to decrease the number of n in our case. So how can you rewrite this expression? This expression can be rewritten like, if we want to find a 2 to the power of 3, it's the same thing like a 2 multiplied by 2 to the power of 2, isn't it? This one is just an equal expression. So the left-hand side and right-hand side, they will be the same by the mathematical or algebraic point of view. So the same thing for to find the 2 to the power of 2. Here we have 2, which means 2 to the power of 2. We are saying that the 2 multiplied by 2 to the power of 1. And the same thing for the third iteration, 2 to the power of 1 to finding this one, which means 2 multiplied by 2 to the power of 0. And in the last expression, in the last step, 2 to the power of 0, as we know from this expression, and we know from our immediate solution, it doesn't matter which number. If the power is 0, the result is 1. And again, this result will be passed and returned to the previous step, which means it becomes the 2 multiplied by 1, which will equal to the 2. And 2 to the power of 2 we already found. And this one passes to the previous step, and it will be step multiplied by 2, which is a 4. And 2 to the power of 2 also defined, already found, and it will be passed to the previous one, which is a 4, and result is 8. And this solution, we solve it on the paper. So in your case, on the paper. And this complex task was separated like this. 2 multiplied by 2 n minus 1. And in our case 3, and here we have n minus 1. And in our case 2, and here we have n minus 1. 1 and n minus 1 is 0. And this is our solution. Return. Everywhere we have the 2, which means our a. It's our base value. A multiplied by, we're calling our function. And a will be the same, but n will be decreased by 1. Which means we are just simplifying our complex task until we will reach this, our base case. And that's it. Run it again, 2 and 3, as you can see, the same result. As you can see, the same result as we did before, but we can do it in 2 lines, 3 lines. But you have to understand what's going on inside it. And this separation, identifying the base case, it's just a challenge for you when you are solving the problem using the equation. Okay, and your homework is to implement the minus sign exponential. If I'm passing the minus 3 now, you will go to segmentation fault. Why? Because for our equation function, if the n is negative, let's imagine that n is negative. In that case, we have here the minus 3, and this number will be decreased infinitely. And that's why you are getting here this you're getting here, which is segmentation fault. It's just a Stack Overflow because this number will be reached, and that's why it cannot stop the working. And your task is to rewrite this code to implement the minus sign. Negative exponential value. Power of minus 3, which is equals to 0.125. And this one is your so the power Fibonacci also will be a homework. So about the Fibonacci, you already know what is the Fibonacci, and Fibonacci is it's a sequence which will start from 0 and 1, and all the next elements will be the T1 plus T2. It's a sum of the previous 2 values. If n equals to the 6, so result should be so that 0, 1, 1, 2, 3, 5. So the next element is just a sum of the like this. If I'm entering the 6, you have to print out this sequence. Implement F1 and F2. And what is F1 and F2? You already know from this. F2 is the regression solution. Okay, so I will show the last example, like maximum from the given from the given array. So let's define the array 2, 10, and 7. So an integer n is inside the array. So again, you have to create f1, which will take the arguments a and n. So how can we pass the array to the function? You have to just write the name of function. The function, you have to define and you have to get this value as an array. So and let's implement it. If we are working with the integers, we are returning the input. As you can see, first argument, it's an array of integers. If we're taking the integer, so it says it cannot identify the function, which will take the array as an argument. That's why you have to put here the as an array. Integer n as a one number. And after that, as you can pass this array to the function. When we are passing the array to the function, we are passing only the address of the first element of the given array, as we discussed before in the previous lectures, and that's why we are passing here the separately number of filters. Okay, our task is as a traditional given array. Any ideas? How can we find the maximum value? So again, it's just a simple, a very simple task. Again, I am talking about the interim. And interim will be the more complex task than this one. That's why we are assuming that this finding the maximum or minimum from the simple array is just tasks for the first station and differ until the midterm. And if you cannot solve this problem, which is a simple one, you will have the very big problems in the end term. That's why please prepare yourself. Okay. We are assuming that the first element of the given array is a maximum, and we will start comparing all the values until the end. And if the current element of the given array is more than our maxi, in that case, maxi will be updated. Maxi will be updated to this element. And after the for loop, we want to return them, maxi value as a result. So 11 CPP, 11 CPP says 10 is the maximum element. And this one is correct. And this solution is correct for the traditional method. And the same thing you have to do for the precaution. Integer a as an array and integer n as an integer number. Again, let's discuss here quickly. So f2 and first argument is the array of these numbers. Array of these numbers, and the size is 4. So the base case. So what is the base case when you are finding the maximum or minimum number from given array? Any ideas? If you don't know how many elements you have inside of the array, you cannot immediately answer to the question, where is the maximum or minimum array? Minimum value inside of this array. So think about the question. How can you immediately answer to the question if I'm asking to find the maximum or minimum value from given array? So, any ideas? How can you answer to the question immediately without any thinking to find the maximum value from given array? Not especially this array, but any array. What will be if when n equals to the 1? What is the n equals to the 1? What does it mean? What does it mean? What does it mean? When n equals to the 1, what was the purpose of the n? What we are storing inside of the n? N is 4. What is a 4?
It means that
It's an if when equal to 1, so n will be maximum number. So
I think you cannot understand what is n. N it's just a size of the array. In our case, n is 4 because we have here the 4 elements.
yes, so we'll have
What
just
will
one
be
number
if
is a maximum number.
Yes, perfect. This one is just a key point. So when n equals to the 1, which means inside of the array only we have the one element. It doesn't matter which number. We can immediately say that this number is maximum or this number is minimum. So this is our base case. Again, I'm trying to explain. How can you find the base case? Your task is you're given an array and you have to find a maximum number. But if I'm given to you array with the number 100 numbers, you cannot find immediately, exactly, very speedily the result of the maximum number. So the base case is task for finding the immediate result when you have some cases. So that's why we're saying that if n is the size of the array, if n equals to the 1, in that case, we have only one element in our array. And this element will be immediately the result, which means maximum value will be A0, because we have only one element. A0 it's a current element, which is a 1. So not 1, which is a current element. If inside of the array, if we have only one element, which means n equals to the 1. And this one is the base case. So n equals to the 1. If n equals to the 1, in that case, we want to return A0, which is my current element. Otherwise, to solve this problem, as we did in the previous examples, we have to rewrite it to find the maximum value. So if I am writing the base case like n equals to the 1, which is the size of the array should be equals to the 1, but currently size of the array equals to the 4, which means I have to decrease this number. By logically, I can understand that this one should be decreased to reach this one. That's why what I'm doing, I'm saying to find the maximum value in this array, I'm taking the maximum value inside of I'm taking the last element of the array. So this one is 7. And I want to find the maximum value inside of 2, 10, and minus 1. I'm getting the last element as a separate one. Maximum value between the last element and the rest of the array will be the maximum value. So the same thing will be for the next element. So now we have here the only 3 elements, and the size will be also 3. So that's why let's write here like this. F2, I'm passing here the 3 elements, and the size will be decreased by 1, it's a 3. And to solve this problem, again, I cannot understand, and I don't know how many elements we have. That's why I'm saying the last element, which is a -1, and this array will be changed. F2 array size will be changed to 2. I'm taking the last element from the array, so I am just removing this one, and I'm changing the size of the array. Again, here we have the number 2. Here I have the 2 and 10. As you can see here, this one. So you have a little bit more square brackets. So I think this one is also, so this one, oh, this one is also incorrect. So this currently we have inside of our array 2 elements. To solve this problem, I again will take the last element, which is the 10. And 10 will be removed. Here we have the 1. 3 and 4. In the last iteration, here we have the only one element. In the last iteration, let's see. So F2 is our function, and I'm passing their array, as you can see, array, but array consists only from one element, and n equals to the 1, as we wrote in our base case. And we say that if n equals to the 1, in that case, we have to remove the current element, which means this number 2 will be returned as the maximum number. But this value will be passed to the previous step as a result, which means instead of this one selected highlighted point, will be changed to the 2, which means maximum from 10 and 2, which is equals to 10. And as you can see, we found the maximum from these 2 elements. And this result will be passed from to the previous step, and it becomes like a maximum from -1 and 10, which is also equals to 10. We already found the maximum number from the 3 elements. You have the extra point. And these 3 elements will be passed again to the previous step. And here we have the maximum from the 7, and 10, which is again 10. And this one is a result. So this separation, as we did here, should be written here. Return what we are doing. We're saying the maximum. So the maximum, which is just a function. Maximum from the last element of the given array. Last element, how can I get the last element? It's a n minus 1. It's the last element. I am taking the last element and calling the function. So the current function, but so size should be the changes. So this size should be the changes. So a is just a link to the first element. That's why I cannot change a with the a anything. But n will be changes, n minus 1. So if n initially equals to the 4, when I'm calling it here, n becomes as a 3 as we did here. And the 3 elements will be checked. And when n equals to the 3, it becomes as a 2 and 2 elements checked. And after that, it will becomes as a 1, and n becomes as a 1. In that case, we will return the value, which is the number 2, and it will go up, or go up, and the result will be the same. So we want to add here the function 2, which is a recursion function, and put the space between them. 11 and run it. As you can see, we have here the maximum number. If you are changing it to the minimum, so that this function, if you are changing to the minimum, it will be the same thing, but it will find the minimum number. You have to just change this comparison operator to the opposite side, and you will have in both functions, you will have the minimum value from given array, which is a -1. So if you are changing it back to the opposite side and you will have the opposite one, you will have the result. Okay, so the last one, is also your homework. So I want to explain what is this. To finding the binary number. So the 0, 1, it's a number 2. Oh, sorry, it's a 1. Number 2, it's just a 1 and 0, which means 1 multiplied by 2 to the power of 1 plus 0 multiplied to the power of 0, which is equals to the 2, because this part becomes a 0, this part will be equals to the 1. So I'm showing the converting from binary number to the decimal, but your task is you are given an integer number. Your task is in decimal format. Your task is if n equals to for instance 5, you have to print out the binary format value of that given decimal number. For instance, for 5 number, if it's a 5, it will be the 101, which means, so I'm showing like this one, and this one, it's the values from here. So this 0 is here, this one is here. So starting from the right hand side, there will be the multiplication of the 2 to the power of 0, 1, 2, 3, 4, and so on. So here we have, the 1 multiplied by 2 to the power of 0, which is the first element, plus sign. Here we have the 0 multiplied by 2 to the power of 1, which is the second element, plus sign, and last one multiplied by 2 to the power of 2. So as you can see, this one, it's the least significant one. This one is a middle 0. This one is a least left number 1, and the result is 5. Here we have 1, here we have 0, here we have 4. 4 plus 1 is 5. And your task is implementing input is there and output is 0. Implement F1 and F2. F1 and F2, you already know about it. It's a simple solution and solution with recursion. It's the end of today's lecture, and time to your questions. Please raise your hand and say the number of example where you have question. We have only the 33 students online. I think the other students will just see the record and watch record today's lecture. Okay, so raise your hand, guys. Any questions? Вопросы какие-нибудь есть? Сұрақтар? Серік болсын.
I want to ask about base case. So why we should write and why it needs for us.
Example here. It's a third example, which is a just simple example. So inside of the main, I'm calling the function show2. And show2 itself calls it, inside it show2, which means it's a recursion function. But we don't have any base case. So as you can see, we don't have any condition here. And in that case, as we discussed before, it will be the Stack Overflow because it cannot stop your function. So the calling your function. Function itself calls infinity times. And after some time, after the stack fields of the maximum size. After that, your computer will just throw the exception, like a Stack Overflow or a segmentation fault, that it cannot be finished correctly. And that's why we have to be careful and write correct base cases to stop your function. Okay. Any other explanations need? Eric Paulson?
Yes, I understood. Thank you.
Okay, any other questions, guys? Okay, any other questions? Questions might be in any language. But today's lecture and today's topic is a little bit confusing and complex. And there should be many questions. I think the questions will be the in practice lessons because you have to think about examples, which we did here. So I'm adding these examples to the GitHub repository. So the recursion and group number 3. So I already added them to the GitHub repository, and I think you have to work a little bit more than in the previous attestation because many of you have to take them as many as possible point to pass to the final exam. That's why please prepare yourself to the practice lesson and ask more questions if you are shying to ask during the lecture time. Again, questions might be in any language, even in practice lesson. Okay, if you don't have any questions, we can finish today's lecture. I'm